This is America in Space, a weekly news and information program on current events dealing with the space industry.
Welcome, and thanks for joining me today. I'm Dawn Meyer, Space Coast News Editor. The Peregrine lunar lander launched on January the 8th, 2024 on the first ever mission of a Vulcan Centaur rocket from United Launch Alliance. The lander had 20 payloads for a variety of customers, including 5 scientific experiments for NASA's Commercial Lunar Payload Services program. The lander also carried memorial payloads of human ashes from the companies Celestis and Elysium Space. Peregrine's mission was to deliver these payloads to the surface of the Moon. However, that plan ended by a fuel leak that occurred shortly after liftoff. The problem was later traced to a ruptured oxidizer tank. However, despite the propulsion anomaly, the Peregrine lander also made it all the way out to lunar distance, then was able to loop back on a collision course with Earth. Astrobotic, working with NASA, developed a plan to make the return impact as safe as possible, and Peregrine returned to Earth on January the 18th, 2024 in a safe, controlled re-entry to Earth over a remote area of the South Pacific. Here is John Thornton, the CEO of Astrobotic, to explain what happened to Peregrine and, most importantly, what worked.
Just want to say right off the top what a wild adventure we were just on. Certainly not the outcome we were hoping for, and certainly challenging right up front, but man, it got really exciting through the course of it, and there's a lot of story to tell here. So just to kind of rehash where we started, we launched on a United Launch Alliance rocket, taking off at 2:18 a.m. in Florida. It was a beautiful, perfect launch that went right at the beginning of its window. It was a true thrill to watch the launch from the roof in Florida and see the vehicle take off and blast Peregrine up to space. It was exciting to see the second stage ignite successfully and to watch all the way through a really perfect injection. ULA nailed it and sent a just perfect bullseye for the injection for where we wanted to be. At that point, that was when our job started. And one of our big nail-biting moments first was, will the lander turn on and start communicating back to Earth? And within a couple minutes of the opening of that window, we had comm. Power was up, spacecraft was operational, and things were looking good. And as we continued to turn on the spacecraft and initiate systems, within about 2 hours of the first turn on and communication, the propulsion initiation occurred, and that's where the challenges started. So the first parts of propulsion initiation worked really well. We were seeing balancing of pressures in the tanks as some of the valves started opening. Everything looked nominal. One of the final steps of that initialization is the firing of a valve to open the helium to the fuel side and the oxidizer side. The fuel side appeared to open successfully. The oxidizer side appeared to have a problem. And we believe that our leading theory has not changed at this point. We're going to be looking at this very heavily with a anomaly review board. But what appears to have happened is that valve connecting the helium to the oxidizer did not properly reseat and sent a rush of helium down into the oxidizer side. And I describe it as a rush because it was very, very fast. Within a little over a minute, the pressure had risen to the point in the oxidizer side that it was well beyond the proof limit of the propulsion tank and the oxidizer side of the tank. And we believe at that point the tank ruptured and led to, and unfortunately, a catastrophic loss of propellant at that point for the primary mission. I'll always remember the moment at Mission Control at ULA when we were coming from the highest high of a perfect launch and came down to a lowest low when we found out that the spacecraft no longer had the helium and no longer had the propulsion needed to attempt a moon landing. So that was certainly a tough moment for all of us. But what happened next, I think, was pretty remarkable and inspiring. Our mission control team in Pittsburgh kept their cool. They focused on the problem, and they diagnosed what occurred, and working with a clock on, because we had a problem where our solar panels were not oriented to the sun. we had just 6 hours between letting go of the launch vehicle and when the battery would run out for the team to diagnose what occurred, figure out how to fix the situation, and get us sun pointing once again. And literally within 4 minutes of the beginning of a loss of signal, expected loss of signal with the spacecraft that was going to likely cause the batteries to go down to critical or probably 0% and kill the spacecraft, one of our engineers on console, along with the whole team, was able to establish a solution and sent a command with 4 minutes remaining before that LOS to reorient the spacecraft and save the mission. But of course, we didn't know it at that moment that it had worked. We had to wait the entire LOS period to find out if that maneuver had worked. And it was quite a thrilling moment on the other side of that, to finally see the batteries starting to tick back up and the solar panels starting to generate power and provide power for the spacecraft. So that was a remarkable moment and a real, I'm just so proud of our engineering team and our mission control team for keeping its cool and working the problem and trying to find a great solution to keep the spacecraft alive. And at that point going forward, for the next several days and hours, we were focused on the fuel and trying to model what was occurring. Originally, the hole looked pretty big, but interestingly, over time, we actually think our current leading hypothesis is the tank, as it was lowering its pressure, started to seal the hole up a little bit, and the leak progressively got smaller and smaller through the course of the mission. And by the end of the mission, the leak was no longer the dominant issue with the spacecraft. So, of course, we didn't have enough fuel to do very many maneuvers, but it certainly changed over the course. We did continue to fly very successfully on our way out to the moon. On the way out, we activated all of the payloads that had power or could use power during the mission. We received successful signals from all of those payloads, and we got data back from all of the payloads that could send data. We were very pleased to see that. Interestingly, many of those payloads and that data, they were not intended to be turned on between Earth and the moon. And because of this anomalous state of the spacecraft, we decided to get as much of that as we could. And interestingly, a lot of those payloads were able to report some interesting data and some level of success from that. When we got back out towards the moon at about lunar distance, just a quick reminder that the moon was not there because we were doing a phasing loop around Earth, so the moon would have been back if we had gone back to Earth and back around out to the moon again. When we reached lunar distance, that was one of the first times that we got an updated trajectory analysis, and what that showed is that the leak that had occurred had done two things. One is it had veered us a little off course. You could think about it as like a left or right off course, but it had also slowed down our trajectory, and it changed the impact, it changed our trajectory to indicate that if we did nothing from that point forward, that we were very likely to return back to Earth. And at that point, we're talking Saturday, the 13th, we were assessing all of our options and trying to figure out what the next right path for the spacecraft would be. We reached out to our partners at NASA for their assessment as well. And that evening, we were faced with a very difficult decision on what to do with the spacecraft. We had an option of attempting to use our propulsion system to avoid Earth and go back out to the moon, or hold steady and have the spacecraft maintain the trajectory it was already on and intersect the Earth. At that point, we made the difficult decision, upon receiving recommendation from NASA, as well as looking at our own data internal, we made the difficult decision to do nothing and to not take the risk of firing those engines and to let the spacecraft fall back toward Earth. We did the best we could with the data that was available at the time. And then as we came back toward Earth, we continued operations and got as much from the spacecraft as we can. And then in the last few couple days right before entry, we felt it was necessary to do some maneuvers right at the very end of the mission to make sure that we could end up with a safe splashdown at the very conclusion of the mission. We did those maneuvers, which was again a proud moment for me to witness mission control and see what they did. We were able to activate the engines, We were able to fire all 5 main engines. We were able to maneuver the spacecraft in a unusual way. We were not able to fire the engines continuously. We had to do a series of small pulses. Those small pulses maneuver us away and put us out into a nice, safe location out in the ocean. The final maneuver was very clever because they figured out and had characterized the leak at that point and figured out that if we could turn the spacecraft, we could actually use the leak to our advantage as essentially a continuous small propulsive maneuver that could push us further out into the ocean. So yesterday at around 3:50 p.m. we lost telemetry with the spacecraft, and 3:59 p.m. Eastern we lost ranging with the spacecraft, which aligns with our projected impact or projected re-entry at 4:04 p.m. Eastern. So since then we've been sharing images and video of the mission, and I'll just reiterate once again how proud I am of the team and the mission control folks and everybody who's been involved with this program from the start. We did not achieve the primary objective of landing on the surface of the moon, but we had an anomaly, and after that anomaly, we just had victory after victory after victory, showing the spacecraft was working in space, showing that the payloads can operate.
Thank you so much.
And getting data back from those payloads and sending as much as we possibly can. So again, I'm just thrilled to be and honored to be a part of this team, and it's really been a special experience that I'll remember for the rest of my life. I do just want to read one quote from one of our payloads that did receive data, and this is a quote from Thomas Berger of DLR, the German Space Agency. And they had on board a radiation detector, so I'll just read this quote. The DLR M42 radiation detector was working perfectly throughout the whole mission timeline. We were able to gather over 92 hours of data measuring the radiation environment in free space during the mission, which is extremely valuable for the science community and for DLR. So I think we were very happy at the end that even despite our anomaly, we were able to get some good science data for our partner for DLR.
Thornton continued with praise of what worked and their next steps for Astrobotic.
We really, really, really wanted to land on the moon this time. We really wanted to get there. That's been our company's heart of hearts mission and goal for 16 years. We didn't reach it this time, and that was difficult, and that was challenging to hear that news when we had that anomaly. But what lifted us up is really what happened next and all of the fantastic work that occurred from there. At that point, we knew we couldn't land, but at that point, we knew we had a spacecraft. We knew we had an orbiter that was in space. It was alive. Astrobotic had its first spacecraft in space, and it was still going. So from there, the mission changed. It was all about keeping the spacecraft alive. It was about once that was stabilized and the life support was supporting the spacecraft, then it became about activating payloads and trying to get as many wins as we can through the course of it, given the anomalies and given the challenges. One thing, though, that I am proud of is our goal as a company is to make space accessible to the world. And though this mission did not turn out the way we had planned, I'm really excited and proud of the fact that the world followed us and they were with us and they experienced the thrill of the space flight and the sorrow and the challenges and just the emotional roller coaster that goes with that. I'm proud of the fact that people followed along and carried with us, and I look forward to making all of those folks proud of us when we do succeed, and all of the folks that have supported us through the course of this. So it's been quite a journey, and I know it's very easy to focus on the failure and the one thing that failed on this spacecraft, and we're all going to have dreams of that for a long time to come. But there's a lot that worked, and that is something I'm very proud of. The Astrobotic design and built hardware, like avionics and software and systems architectures and other parts of the spacecraft, they all worked. We were getting images and video live back. Telemetry was working, comm was working, power was working, solar panels were working. There were so many parts of the system that worked. So even though we had that anomaly right out of the gate, it felt like we were so close. That's why I really feel confident that the next mission to the moon will be successful. We know what this anomaly is. We have the team. We have the mission control team that can basically handle any stressful situation. And I think if we get a good spacecraft built up, I think we're going to land late this year or with the Viper program. So from here, our next steps, we're going to be very focused on analyzing this anomaly, make sure that our leading try to figure out exactly what occurred. As of now, our leading hypothesis has not changed, but we're going to be assembling a review board of many experts from across the industry to take a close look at this, to figure out exactly what happened. We are already assessing what those impacts could be for the Griffin program to make sure that this kind of anomaly never happens again. And we also are making sure to incorporate all of the successes of what worked on the Peregrine mission into the Griffin program to make sure that Griffin is successful. That mission is still scheduled for the end of this year, where we'll be flying once again, and I'm very much looking forward to that. And I can just say that I am more confident than ever now that our next mission will be successful and land on the surface of the moon, just seeing what our team did, what they went through, and what they overcame to get us to the unexpected but very exciting mission that we ended up with.
I look forward to their next lunar flight later this year or next, and their future flights. Thank you for joining me. Listen each Tuesday for This Week in Space with John Gomez. And join me every Friday for America in Space. From the Florida Space Coast, I'm Dawn Meyer, Space Coast News Editor for About Space Today.
Thanks for listening. Be sure to share our program with your family and friends and follow us on Facebook. Join us each week for news and information on America in Space.